Okay, so step 2 of understanding the Knuth-Bendix completion is to understand what is superposition of critical term. I'm going to define it over the next few slides on what is it about. So suppose we have a critical term and the non-rewrite proof can be constructed by reducing the term into alternate normal forms. So like what we've seen in previous slide. So the two rules will be applied to it. Okay, so or one rule in two distinct ways. The critical term must appear in two separate instances of the left-hand side of the rewrite rules. Because in order for it to simplify, in order for us to apply two rules, okay, and simplify the critical term in two different form or two different term, okay, the critical term must appear or must be similar to the two separate instances of the left-hand side of the rewrite rules. Okay, so superposition is the idea of unification of the left-hand side of the rules, okay, which I'm going to explain more later. By the way, unification is the process of finding substitution of terms for variables in both t and t prime, where t and t prime are two terms that are rendered to be identical. So for example, we have 0 plus a plus negative a is identical to x plus y plus z. So by unification, remember we treat this something like a blank. Okay, so we fill in this blank with 0. Okay, fill in the y blank with a and fill in the z blank with negative a. Okay, but this is the most basic kind of unification. There are more complicated unification that are used for theorem provers and stuff, or computer programs. So there are a lot of papers on it. So however, I will not discuss this because as this is a very hard topic itself as well. So yeah. So first we need to understand what is a subsumption ordering. So the idea of subsumption is that if t subsumes t prime, okay, if only if, okay, t prime can be, okay, so this is a mathematical formulation for it. So I'm going to just explain in terms of layman term. T prime can be from another term t by making substitution of variables of t. So sort of t is a more general form than t prime. So t prime, we call it t prime is an instance of t. So for example, t is negative x plus x. T prime can be, you sub in the x with another term t prime. So for this case, our t prime will be a plus b. Okay, with every occurrence of x. So here will be a plus b, a plus b. So this is an instance of this. So there's ordering that we will define on it, which is greater than or equals to subscript t. Okay, so this means that t subsumes t prime, which means t is more general than t prime, which means t prime is an instance of t. So I'm just repeating myself. Okay, so the conclusion is that t is more general than t prime. Okay, whenever you write this, t prime is greater than or equals to t. So this is sort of more complex compared to t, but then t prime is just by making substitution of variables of t okay. So by the way, in fact, this is pre-ordering, and suppose neither this or this holds, then they are related. Okay, but we're not going into that. Okay, so over here, we will use this representation to represent the set of all instances of t. Because by right over here, minus x plus x, you can sub with a, you can sub with b, you can sub with a plus b, you can sub with a plus b plus c, or any other terms over here, okay, with all occurrence of x. So all these instances of t, okay, we label as t star, and this is the representation. And by the way, this is the infinite side because, as I said already, you can make a lot of different, there are infinite terms that you can generate and replace this x itself. Okay, so instances of two terms are actually the critical terms. Suppose that T1 and T2 over here, okay, are the left-hand sides or subterms of the left-hand side of the rewrite rules. Okay, unification of T1 and T2 is precisely to find, okay, the critical terms, okay, which is defined over here. Okay, this is the representation of all instances of T1. This is represented all instances of T2. Okay, the intersection between these two sets are precisely the set of critical terms which both rules can be applied. Okay, so this is the critical term that we wish to find, okay, using both of these left-hand side of the rewrite rules. Okay, so with that being said, I just show you the example of how we discover the critical term negative a plus negative a plus a. So this critical terms is found in the previous example when we're trying to prove negative a equals to a. Okay, you can go back a slide and see this is a critical term and we are looking at it. So how can you discover it? Remember that discovering of this critical term, all these critical terms are important. So let's see. So we need to remember that we need to unify the left-hand side of any two rewrite rules. So for example, now we have R3 and R4. We can pair with R1 and R4, all this, but for this example, to discover this, we will pair R3 and R4. So R3, the rewrite rule is this, and R4, the rewrite rule is this. Okay, let's look at left-hand side. Okay, so we have negative x prime. I use x prime instead of x because not to confuse with the x from the other side. Okay, after all, from their point of view, from the machine point of view, they are just blank. Okay, free variables. So the left-hand side of the R4 over here is x plus y plus z. Okay, can we unify them? Okay, you can check yourself, and we are unable to unify them. Okay, so doesn't mean you must unify the left-hand side and left-hand side. We can try and see whether any subterms of the left-hand side, we can unify them. So here, okay, if you get a subterm which is over here, okay, x plus y, you can unify with the terms over here, negative x prime and x prime. How? Okay, by making unification of or substitution of x with x negative x prime, and for every occurrence of y, then you replace with x prime. Then you can unify them and state that they are identical. Okay, so if you just replace, and z will be free. Okay, because over here we never unify. So we unify, replace this and this. We render this as identical. Render y as identical as y prime, x as identical as negative x prime. Okay, so keeping this the same. Okay, we're gonna replace the x with negative x prime, the y with x prime. Okay, then after that the z will still be free. Then after that, same over here, the rewrite rule over here will still be the same. Okay, so now after unification, the R3 will still be the same. R4 will sort of change in terms of this form. Okay, and with the correct substitution of minus a, okay, with x prime and z with a, we will be able to see the rewrite rule of R3 will evolve to this, and the rewrite rule for R4 will become this. Okay, if you look at this left-hand side is what we are trying to discover. Okay, so after superposition, so from here, the critical term negative a plus negative a plus a now can be written into two rules into two terms. Okay, over here. So for R4, we just apply the modified R4 we have over here, and we'll get to this term. Okay, and for this R3, we are not using any of this plus a. We just rewriting this part, this subterm using R3. Okay, which is okay, over here to 0. Okay, and then we get to this. Okay, so the process, and these two terms we are calling the critical pair. So this is the critical term, this is the critical pair with respect to this critical term. So superposition is a process of finding a critical pair by unifying subterms. Okay, the whole term itself is considered a subterm as well. Okay, by the way, so subterms of the left-hand side of two rules. So the process of finding, so this whole process that I went through just now, okay, but without specifying the A, okay, is superposition. So I repeat again, by trying to unify two left-hand side of two rules, and this process yield a critical pair, okay, and this process we'll call it the superposition, okay, and the unifying of this left-hand side of the rules will give you the critical term lah, okay. So, but the set of critical terms generated by T1 and T2, which is T1 star intersect T1, T2 star, is infinite, as we can see that each of the instances for T1 and T2, you can put a lot of different substitution and stuff. Okay, so it's infinite. Not a lot, like infinite possible substitution. Okay, you can substitute any variable of A with A plus B plus C, or change A plus B or whatever. Okay, but which superposition should we select? Fortunately, by the work of Robinson, okay, if unification of two first order terms is possible, you'll use a single and most general unified up to renaming of variables lah. Okay, so for in this case, okay, this let T3 star represent this T1 star intersect T2 star. Okay, there will be a peak over here. Okay, so this is T3, and this T3, okay, is the most general unified terms. So this goes to show that all we need to do is just unification of superposition or unification of the left hand side of the two rules, okay, of the general term, and we do not need to care of any other substitution, any other form of substitution of the two rewrite rules. All we need to do is the most general form of the two rewrite rules, and we superposition it, and we get, okay, the critical term. Okay, so this, they will give you the most general based on the work of Robinson. Okay, we will know that, okay, we are able to get the most general unified form, so we do not need to worry about the rest of the superposition to select that we may wonder whether to select or not. So no worries, because of the work, okay, we can just find the most unified, most general unified term. Okay, so let us, using our R1 to R4, we can superpose, okay, all the pairs of rewrite rule, and we get to this all this superposition. Okay, so R1 pair. Okay, so the whole sort of whole pairing goes like R1. Okay, we will try to pair with R1, then R1 with R2 as well, R2 with R3 as well, R1 with R4 as well. So same go for R2. So since after that this is paired already, so R2 with R3, so R3 with R4. Okay. Oh, remember R2 must with R2 as well. Okay, this one I just now I forget. Okay, so other than, so lastly, next R3 with R3, and R3 R4 also, and lastly R4 and R4. Okay, so all these are possible pairing that we can have, but R1 and R1 will not yield any good superposition that will be useful. So out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, only 7 of them, okay, will be useful, will give a useful superposition. So these are the 7 pairs of superposition. So superpose of R1 and R2, you get this critical term, and these are the critical pair. R2 and R3 will get to this critical term, and these two are the critical pair, and so on and so forth. Okay, so remember that you can pair with yourself as well. Okay, but just that we look at different subterm. Okay, and this is the form. Okay, so after we get the two critical pair, okay, we try to normalize it, which mean to reduce it. Okay, eventually if you look at it, out of this 7 pair, okay, 1, 2, 3, 4, 5 of them, okay, eventually will go back to the same normal form. So eventually, so what this saying that even if you have superpose, if you superpose, Okay, it will not yield any more information that we already know, because you superpose it to two critical terms, like for example for this, the critical pair, two terms in the critical pair. Okay, eventually if you normalize it, it go back to the same thing again. So the rewrite rule never give us any more information that we already know. However, if you look at these two terms, okay, if these two terms are at their normal form and we cannot simplify it even more or reduce it even more, so these two critical pair is important. Why? Okay, essentially if you look at this, we know that, okay, although we cannot normalize it, okay, to get the same normal form, but if you see here, negative 0 is arrowed from negative 0 plus 0. This means this equals to this equals to this. So we can say that this will be equals to this as well, correct? Okay, so same over here, we can say that this equals to this. So because of this, okay, so the two critical pairs just now we mentioned, okay, have no rewrite rules, okay, but they are equal nonetheless, as I explained just now. So it's reasonable to add this equation as new rewrite rules, okay, such that negative 0 will rewrite to 0. Okay, in terms of the complexity, remember the left hand side must be more complex than the right hand side. So here also, okay, so same, okay, remember this, okay, we know that this chain are all equal, okay, and however these two are their normal form already, so we cannot even simplify them, but we can make it to a rewrite rule, okay, for more complex term to a less complex term. Okay, so what is the consequences of adding such rule? Okay, proof can be simplified and new superposition can be considered, which may lead to even more new rules, rewrite rules. Okay, I'll give you an example. Okay, suppose we have this. Okay, if you see this, right, remember this is the similar example that we have for the negative a and stuff. Okay, so remember negative a equals a, but this is in terms of we don't use specific a, we use x as a free variable, okay, to use it. Initially this, okay, was from this path is we need to rewrite R3 to R1, then eventually you get to this. But over here, after having this new rewrite rule, okay, the proof is simplified and we can write with just R10 itself. Okay, and okay, because of this, okay, over here, this is simplified form, normal form. This is normal form, and we do not have a their two normal form are not the same. However, they are still equal. Remember the path we have equal. Okay, so here we can generate a new rewrite rule that negative x equals to will arrow to x. Okay. By the way, the renaming R9, R10, and R11. Why not R5, 6, 7? Because later we're going to show the full proof, okay, of the whole Knuth-Bendix algorithm, and this is the ninth like rewrite rule they generated. So yeah, we just follow it. Later you see why. Okay. So as I said, adding new rules will give you simplified proof. Okay, and new superposition can be considered because of this. Then after that, we can generate a new rewrite rule from here. Okay. So this is a superposition of R3 and R10. Okay. So let's summarize what we have. Okay. For negative a equals a. So initially, okay, we have this. Okay. Equational axiom, 4 of them. We try to write the proof. Okay, so left hand side go all the way to right hand side. So the bad thing is, remember that this one we can go from left to right, right to left, which means you can go from less complex to more complex, then go back again. There's no fixed method or certain procedure, systematic way for the machine to recognize which rule to use. Should I rewrite to left to right, right to right, right to left, or whatever? Okay, so we introduce the rewrite rules, and eventually we get, for this case, we will get a non-rewrite proof. Okay, which give you a complex term, and as I said, the complex term, some of them may be very difficult to find. Okay, so over here, we learn how to generate by superposition new rules. Okay, As a result, we have new rules over here. Okay. After having these new rules, superposition of R3 and R10, okay, of the new rules we have R10, okay, we simplify the, what do you call it, our proof, and eventually add in another new set of rule, like negative x equals arrow x, and now we will have a straightforward and rewrite proof, okay, from negative a straight away to a, because of the new rule that we generated through the process of superposition of whatever rewrite rules we have, okay, and we will get the new rewrite rule. Eventually all this, okay, will narrow down to just a rewrite proof of negative a to a. And this rewrite rule is possible because of the superposition of all the initial rewrite rules and the new ones. Okay, remember that. Okay, this shows an example that how we are generating a set of rewrite rules such that all theorems for this case is this negative a equals to a, okay, can be proved by rewrite rules. So initially it's a non-rewrite proof, we make it to a rewrite proof. Okay.